Welcome back, everybody. Today we're going to be doing some equations with collecting like terms. Let's see what that looks like. It's an equation like this one. Notice, we've always said that the name of the game in algebra is get the letter by itself, or to isolate the variable. So in this situation, what you're going to notice is that I've got 6y here, I've got 3y here. So I've got a y here and a y here. In order to isolate the variable, I need only one set of y's. So let's see what this problem actually looks like. Hopefully you notice that I've got 6 y's and 3 y's. And all of that equals 36. Well, what I'm hoping you've realized is that if we have 6 y's and 3 y's, just like I have 6 cookies and 3 cookies, I could easily say that I have 9 y's here just as easily as I could say I have 9 cookies. So 6 y's plus 3 y's will equal 9 y's. Now that we've gotten to this point, it's back to being a one-step problem. And if it's just a one-step problem, then all I have to do is use my division property of equality to be able to divide both sides by 9. Notice each of those y's is there in each group, and each of these groups would be a 4. Once we scroll this back, you're going to notice that each y equals a 4. If you want to check to see if you're right, all you have to do is plug in. 6 times 4 would be 24, 3 times 4 would be 12, and 24 plus 12 would equal 36. So when there are like terms in an equation, we always collect them before using the addition and multiplication or division properties. Let me show you. So in the situation, before using the multiplication or division properties, we collected the like terms into one group of y's. Once we got here, we used the division property to divide by 9 and divide by 9. And we got y equals 4. Always check your work, and you can know if you got the right answer. We could do this using a two-column proof. Once again, why did you choose to do this problem? Oh, that's right, it's the one I gave you. Why did we combine the like terms? Oh, that's right, we were collecting things that were alike, or collecting like terms. We used the divide by 9, that is the division property of equality. And then when we simplified, we got our answer. Are there any questions? Let's see if you guys could try this one. If you want to pause, now's the time to pause. Okay, we're back. Again, why did you decide to do this problem? Oh, that's right, it's given. And so, we have two groups of y's here. Since they are both y's, we can combine them. And so we can make it into a negative 14y. What did we do? We collected like terms. Now that we have the y, a single y, we can use the division property to divide both sides by negative 14. And once we simplify, we get our answer of negative 4. Did you get it? Let's try one more. And this one we're going to make just that little bit longer. So here's the problem. Why'd you decide to do this problem again? You got it. It was given. Okay, so the very first thing I want you to notice in this problem is that you have things that are alike. And we can always combine like terms first. So once we've collected the like terms, doesn't this look like a two-step algebra problem? And we can solve that by doing the addition property before the division property. So when I subtract the 12 and subtract the 12, I end up getting negative 3y equals 21 after I simplify. And now I can use the division property of equality to eliminate the negative 3, and I end up getting y equals negative 7 after I simplify. All right. That's how you can solve problems that have more than one variable on one side of the equation. And we'll be talking about a couple of other types of problems with parentheses tomorrow. Hope you guys have a good time or a good night, and if you have any questions, please feel free to email me. Thanks.